Okay, so today we will discuss the M2 January 2022. We'll start with question number 1. A particle of mass 0.5 kilograms is moving with velocity 2y plus 4j meters per second when it receives an impulse of minus 4y plus 6j newton seconds. Find the speed of the particle immediately after it receives the impulse. Okay, so what's the equation we have to use here? I equals mv minus mu. mv minus mu, and in here they have given you the impulse in terms of I and j. All you have to do is to substitute. So the particle of mass 0.5, the impulse it receives is minus 4i plus 6j. So I prefer writing the column vector. You can write the whole thing as it is if you want, minus 4i plus 6j. The column vector is a lot easier. Minus 4i plus 6j is the impulse. Mass is 0.5. V is the velocity after the impulse, right? So I'll name it as, leave it as V. Minus mass is 0.5. U is initial. So 2i plus 4j. Simplify this. Minus 4, 6, and I get here plus 0.5 times 2, 4. 0.5 we simplify. Minus 4 plus 1. That gives me minus 3, right? 6 plus 2. Equals 0.5v. 0.5 is a half. So when the half goes to the 2 will multiply with both the elements. So final velocity element will be minus 6 and 16. Minus 6 and 16. So basically this means your final velocity is minus 6i plus 16j. Minus 6i plus 16j. Okay. So then however, you can see the question they are asking you to find the speed of the particle. So what do you mean by the speed? Now we have the velocity. So to get the speed, we have to find the magnitude. Get the magnitude. So to get the magnitude, minus 6 square plus 16 square square root gives us how much? 36 plus 16 square. I gave minus 6 square is 36. Square root of that answer, square root 292 or 2 root 73. Is that okay? 2 root 73, and your speed will be in meters per second. You can give your answer to 3SF if you want. However, they haven't asked us, so you could leave your answer in exact form. Okay, the next part B. Find the size of the angle between the direction of motion of the particle immediately before it receives the impulse and the direction of motion of the particle immediately after it receives the impulse. So you need to find the size of the angle between the initial direction and the final direction. So initial direction you can find by using the initial velocity, and the final direction you can find it from the final velocity. So in part B, what's our initial direction? Our initial direction is 2y plus 4j. My final velocity was minus 6i plus 16j. Draw this on a diagram. So when I draw it, 2y plus 4j. So this is, let's say, 2. So 2y, 4j. So this is the initial direction. Okay, and then the final velocity, minus 6i plus 16j. So minus 6 is somewhere over here, let's say. Plus 16, let's say it's somewhere over here. Okay, so this is your final velocity. So initial velocity and final velocity we have. So now you need to find the angle, find the size of the angle between the direction of motion of the particle immediately before and immediately after. So you have to get this, you have to get the angle in between these two. So what is the easiest way to get the angle in between these two? What I feel that is easiest is to find this first angle here in between here. Let's say this angle is alpha and I can find the other angle beta. By the way, first of all, do you know what angle you need to find? You have to find the angle in between U and V. So basically you have to find the angle, this angle that I'm marking right now in green. This is the one you need to find. You realize it? The angle you need to find is this angle that I'm marking in green right now. This is the angle or kind of like the deflected angle. Sometimes they can ask you what the deflected angle. So this was the initial direction. This is the final direction. So this is the angle. So you need to find this. So what I'll do is I'll first find alpha and I'll find beta, and what I can use what angles on a straight line, subtract the two angles and find this. Okay, so let's find it. Tan alpha. Tan alpha opposite over adjacent. Opposite is 4. Opposite over adjacent. Adjacent is 2. Get me the value of alpha. Find tan inverse and get me the value of alpha. Tan inverse 2. 63.4. Get a few extra decimals. 63.4349. The next one, the tan beta. Tan beta is opposite. Now remember you are taking the length here. So opposite is 16. Adjacent, take the 6. Don't take minus 6. All I need is the length. So your beta is tan inverse 16 over 6, which is 69.44395. 69.44395. Yeah. And then all we need to do is to get the angle. The deflected angle. So from 180, you can subtract your tan inverse 2, or else I think it's better to do like this, right? And tan inverse 16 over 6. You could type it immediately in the cal also. Or else then you can put the values here. Anything is fine because we use extra decimals. It's okay. 44395. So I get here 47.12. 1211. Okay, so then now they're saying you find the size of the angle. Yeah, they have just said yeah, to find the angle. So we can leave it to 3 SF. 47.1. 47.1, yes. So they haven't, by the way, they haven't told you here whether to do this in degrees or in radians, right? Anywhere. So then you could do this in degree or you could do it in radians. Both are acceptable. Okay. So since they didn't mention I have done in degrees, but doing it in radians is perfectly fine because they have not mentioned anything in the question. A car of mass 600 kg tows a trailer of mass 200 kg up a hill along a straight road that is inclined at an angle theta to the horizontal where sin theta is 1 over 20. The trailer is attached to the car by a light inextensible tow bar. The resistance to the motion of the car from non-gravitational forces is modeled as a constant force of magnitude 150 newtons. Okay, the resistance to the motion of the trailer from non-gravitational forces is modeled as a constant force of magnitude 300. The first things first, you have to draw your diagram. So the car is towing a trailer up a hill. The first thing is you need to draw the diagram. The car is towing the trailer up along the hill. So mark the angle theta. So you have the car which is towing a trailer up along the hill. Okay, and then the car has a mass of 600 kilograms, which means the weight is 600 G. And the trailer has a mass of 200 kilograms, which means the trailer has a weight of 200 G. Okay, then we have told us sin theta is 1 over 20. We could use the triangle and calculate the value of cos theta. Let's just keep it at this right now. The trailer is attached to the car by a light inextensible tow bar. Okay, I have drawn the tow bar. the resistance to the motion of the car from non-gravitational forces. Non-gravitational means it's like friction, right? So the resistance to the motion or friction or air resistance, anything that is non-gravitational, is modeled as a constant force of magnitude 150. So the car is going up the hill. The car is going up the hill, resistance should be downwards. So the resistance to the car downwards is, this is the resistance acting on the car. So the resistance acting on the car is 150 newtons. You can mark them anywhere, okay, just as long as it's acting on the car. The resistance to the motion of the trailer from non-gravitational force is modeled as 300. To just mark it anywhere, I want to mark the weight components also. That's why I'm marking it like this. So this is 300 newtons. Okay, then what are the other forces we have? When the engine of the car is working at a constant rate of p kilowatts. So definitely for the car to move up, what do we need to have? I mean, the car needs to produce the engine force or the driving force, which is forward. That's the reason the car is moving up the hill. So along the plane upwards, we have the driving force produced by the engine of the car. Okay, the tractive force. Okay, then they have said, okay, the trailer, okay, when the engine of the car is working at a constant rate of p kilowatt, the trailer has, the car and the trailer have a constant speed. Okay, so we are going at a constant speed, which means, do we have any acceleration? No, which means when the vehicles are moving at a constant speed, the forces must be balanced. Okay, so the forces are balanced. Okay, so then it's going at a constant speed of how much? 15 meters per second. Okay, so they're asking us to find the value of the P. What is the value of P? P is the power, the P kilowatt. Okay, so we have to find the power. So what is the equation for power? Power equals dV, right? Driving force into velocity. Not just any other force, but the driving force. Power equals driving force into velocity. Okay, so then the power is given as P kilowatts, right? So normally in this case, when we use power here, power comes in watts when we're using this equation. Okay, so driving force, as you can see, driving force is also an unknown. Power is also an unknown. Velocity is known. So first thing you need to find here is what? You have to find the value of your driving force. After finding the value of driving force, we can input it over here and we can find the value of P. Okay, so let's find the driving force. So what are the forces we have on this system? So you have a tow bar here, right? And this car is pulling it up. What are the other forces we have? There are some other forces here, right? What are they? On the tow bar, since the car is pulling the trailer up, you have a what? There's another force acting along the tow bar. Who is it? Tension. Since it's pulling, we can say it's a tension. Okay? So tension acting on the car. And tension belonging to the tow truck, right? Yes. And what else do we have? Complete the force diagram. So we prefer to mark all our forces parallel to the plane and perpendicular to the plane. There's one more important force. Who is it? Friction. Friction in the sense non-gravitational forces be marked. Friction is marked. Who else? The components of, we need to get the weight components. We don't work with the horizontal. We have to get the weight components. In addition to that, we also have what? The normal reaction, right? Normal reaction acting on the car.
Quick question, just a heads up. So, since it's going at a constant velocity, I think we can model it as the thing with equilibrium.
Yeah, this is in equilibrium. These two vehicles are going at constant speed, which means this is in equilibrium. Yes, the forces are balanced. So then let's, shall we break into components, the weights. So what do we have here? The theta will come here. So this is M1, right? This will be 200G. This will be 200G cos theta. This will be 200G sin theta. And then this one, the weight, again theta over here, we have 600G cos theta. And we have 600G. And we have 600 G sine theta. Okay. Okay, so I think I have marked the thrust here, right? This needs to be tension is a pulling force. So this needs to come the other way. Okay, so now what we'll do is, they say here the object is in, they say the particles, the car and the trailer are moving at constant speed, right? So then what you can do here is, you can take the equilibrium of the forces for the trailer, and you can take equilibrium of forces for the car. Okay. So when we consider the trailer, when I consider the trailer, what do we see? What are the forces acting on the trailer along the plane? Along the plane upwards, we have the tension. Along the plane upward, we have the tension. And it balances out with what? It balances out with the 300 Newton plus the 200 G sine theta. Right? Because these two forces, they must be in balance. These are the forces belonging to the trailer. This tension is balancing out with these two. Okay, the forces are in balance. Similarly, go for the car. So when you go for the car, the forces we have along the plane upwards, I have the driving force, which balances out with what? What are the forces we have for the car? We have the 150 Newton, the resistive force, and we have the 600 G sine theta, and plus we have the tension. All these three are opposing. Okay, so all these three are opposing, all of these. So the driving force is equal to the sum of all these three forces. So the T value we have found over here. Input the T value onto this. And I get here D equals 150 plus 600 G sine theta plus the T will be equal to 300 plus 200 G sine theta. Is that okay? Input the value. Get the driving force. 600 G is 9.8. Sine theta is 1 over 20. Actually, shall I add these two? It's at 300 plus 150 is 450. 600 G plus 200 G is 800 G. Sine theta is 1 over 20. Can I have the value for the driving force? What is the value for the driving force? 800 into 9.8 into 1 over 20. 842. Right? 842. Is that okay? 842 newtons. Okay, now let's get the power. So power equal driving force into velocity. So 842 times what's the velocity? 15. 842 times 15 is? Yeah, 12,630. 12,630, you get the power in watts. So however, they want the answer in P kilowatts. So kilowatts means divide by 1000, and the answer becomes 12.63 kilowatts. And this is the value of your P, 12.63 kilowatts. Okay, so the next part. Later, at the instant when the car and the trailer are traveling up the hill with a speed of 20 meters per second, the tow bar brakes. Okay, so later at the instant when the car and the trailer are traveling up the hill with a speed of 20, the tow bar is braking. Okay, when the tow bar brakes, the trailer is at the point X. The trailer continues to travel up the hill before coming to instantaneous rest at the point Y. The resistance to the motion of the trailer from non-gravitational force is again modeled at a constant force of magnitude 300 newtons. Use the work energy principle to find the distance xy. Okay. Once again, let's just draw only our trailer. So we are only interested in the trailer here in part B, right? So in part B, when the string breaks, that means the trailer is on its own, right? At the starting point, we'll say what was the speed? The speed was 20, and now the trailer is on its own because the string breaks, the car will go up, but the trailer doesn't have its own engine. So the trailer doesn't produce an engine force. So what happens? So when the string breaks, now the trailer has already achieved a certain velocity. So because of that velocity, the trailer will continue to move up. However, though now the trailer is continually moving up, does it now accelerate or does it maintain the same speed? No, it will decelerate because there's no one pulling it forward. So it will continue to go up because of its speed, but it will only go up for a short time. Until what? Until its speed reaches 0. Until its speed reaches 0, it will continue to go up. Okay. So the point X, when the tow bar breaks, the trailer is at point X. So this is the point X. And when it comes to instantaneous rest, it's at point Y. Okay, they ask you to find the distance travel, right? That use the work energy principle to find the distance xy. Okay, so basically work energy principle means you have to use you can't use F equal ma, you can't use acceleration equations and get this. You have to use the work energy principle. Okay, so in the work energy principle, what is the main rule? The work done by friction or the work done by the non-gravitational forces. Okay, non-gravitational resistive forces. Okay, work done by the resistive force is equal to what? Work done by resistive force is equal to the change in energy. This is the principle. Work done by resistive force is equal to the change in the energy. Okay, so basically when you have a resistive force, change in energy, is it going to be initial energy minus final energy or is it going to be final minus initial? So that totally depends. You can see here, because it's a resistive force, you realize that some part of the energy is lost due to friction, the resistive force. Therefore, your initial energy will always be higher. So basically, in this case, the change in energy is the initial energy you subtract from the final energy. Okay, so now let's work on this. The first thing is we have to find the distance xy. So let's say that distance xy is, let's say it as d. Let's use the word d. So I had to find this value of d. I have to find the value of d. Okay, so what are the things we need to consider here? When the particle is traveling up along the hill, I think you can see when we talk about its kinetic energy and potential energy. Now you can see initially it has kinetic energy, right? So and you can see the more, and when it reaches y, you can see it's a 0. The velocity 0 means what? It has totally lost all its kinetic energy. Can you see? The initial energy you have is Ke, and Ke is when you go up to this point, your Ke is completely gone, right? So for initial energy, we can use Ke, and you could use a word here, say Ke lost, because the Ke is totally lost. Initially, you had Ke, and when you come to this point, your Ke is totally gone. Okay, Ke lost. And minus, when you come to this point, at the final stage, what energy do we have? You know, you don't have Ke here, but what energy do you have? You have traveled up, right? A certain distance. When you travel up a certain distance, when you go up in elevation, what energy do we gain? We gain GPE. We gain GPE. So I will take this point X as my GPE 0 level. So I will be measuring my GPE from point X. So you can understand at the final stage, I only have GPE. You get it? So this is a GPE and not just a GPE, but a gain in GPE. It's a gain in GPE. Okay? We can use those words. Okay. So then to find the GPE, okay, so I need the vertical height. Let's input the values first. So work done by the resistive force. Our resistive force is how much? The resistive force is still 300, right? They have told the non-gravitational resistive force is 300. Okay, so what is the equation we use for work done by resistive force? Work done by any force is force into distance. Are you with me? So force into distance. Okay, let's get the force into distance. So what's the force? The resistive force is 300. So 300 into what's the distance that the that your object is moving along the along this particular direction? What's the distance that you are moving with the resistive force? You are moving the distance d. Okay, kinetic energy lost half mv square. Half mv square. M is how much? M is 200 kilograms. M is 200 kilogram and velocity that you have is 20 half mv square minus m gb is mgh, right? So mg is 9.8. What is the h value? That is the biggest thing here. When you say h here, can we? I mean, you know, in mgh, the h means the perpendicular. I mean, the vertical height. You can't use a slant height. So how do I get this h here? I need this h value. So can't be resolved here. This theta can be resolved, right? Can you see? So when you resolve, what do you get for h? It is d cos theta or d sin theta. H is equal to d sin theta. Do you see it? Can you see when I use this triangle over here? You can use a triangle like this. So this whole distance is h. This is d. And this is the theta. This theta comes over here because of corresponding angles. Okay? So then d not cos theta but d sin theta. And now what? Make d the subject. Let's make d the subject. 300 times d plus 200 into 9.8 into d into sine theta is 1/20. Is it okay? Equal half m v square. Let's simplify. Let's simplify. I can take the d out. 200 into 9.8 into 1/20 is how much? The 0 to 0 can cancel. The 2 and I get here 10 into 9.8. I get 98, right? 300 plus 98. This is half into 200 is 100 times 20 square. Get me the d value. So I get here d is 100 times 20 square or 400 divided by 398. How much is it? We get 100. Can I know the decimal figure? Do we have a, sorry, the exact figure? No. Yeah, 100.5025. Yeah. And do they want it to 2SF or 3SF? Have they told use the work energy principle to find the distance xy? So we'll make it to 3SF. So it will be how much? 101 meters. Give your final answer to 3SF. Okay, so this is it. I hope you understood the work energy principle. Okay, question number 3. A particle P of mass 0.25 kg is moving on a smooth horizontal surface under the action of a single force F newtons. At time t seconds, t greater than or equal 0, the velocity v of p is given by this function. You can see it's given in terms of I and j. Find F in terms of t. So we have to find the force. To find the force, what is the formula we use? We use F equals ma. To find acceleration, what do we need? They have given us a velocity. To go from velocity to acceleration, what do we know? What do? We need to differentiate. Basically, acceleration is your dv by dt. So I have written here some rules to remember when you differentiation of sine cos, because that's what we need to do here. So let's apply those rules. Our velocity function is 6 sine 3t I plus 1 plus 2 cos t j. Okay, so how do we find the acceleration? Differentiate. So when you differentiate dv by dt, what do we get here? 6 sine 3t, right? 6 sine 3 differentiation, 6 stays out, while sine 3t differentiation is 3 cos 3t. Is that okay? The 3 comes forward, right? 3 times cos 3t. I, and then when you differentiate 1 plus 2 cos t, differentiation of 1 is 0. 2 times cos t differentiation is minus sine. So minus 1 times sine t. So basically in here the x is the t. Okay. This is with J. Yeah, we can multiply 6 and 3 and we get here 18 cos 3ti. And over here I get minus 2 sin t j. Okay, so this is what I get. Then we'll use the equation F equal ma. So F equal m is 0.25 kilograms. Acceleration is, input the value, 18 cos 3t times I minus 2 sin t times j. So input the values, multiply 0.25 when you multiply with 18. What do we get? 0.25 times 18. How much is it? 4.5? 9 over 2? Yeah. 9 over 2 cos 3t times, don't forget the I. This is the I component. And then minus 0.25 into 2 is 0.5 or minus half sin t times j. So in here, they have not asked you to find the magnitude of the force, have they? No. So they just ask you to find the force. In that case, you leave your answer in the vector form. In an event, they ask us to find the magnitude of the force only, we have to go for the squaring and the squaring. Okay, so this is it. This is the answer for part A. Part B, at time 0, the position vector of P relative to a fixed point O is 4i minus root 3j meters. Okay. So at time 0, they have given you the position vector. Find the position vector of P relative to O. Obviously, a position vector is measured with respect to the origin. So you all should know, when you have velocity in terms of ij, how do we go to the position vector? Velocity, if we integrate, we go to the position vector. Velocity differentiated is acceleration. Velocity integrated is the position vector. The position vector is like what? It's like the coordinate, the position, the coordinate, the xy coordinate where the object really is. They say find the position vector of P relative to O when P is first moving, parallel to the vector I. Okay, so moving parallel to vector I, this is something you have learned in M1. Moving parallel, whenever they say this particular person is moving parallel to this vector, what do we equate? What do we take? A movement parallel means moving parallel to vector I. So when you say it's moving parallel, now we have several variables here. We have acceleration, which we have found. We have velocity. We can even find the position vector if we integrate. My question is, when they say the object is moving parallel, what is the first person that we need to that needs to come into our mind? You have to talk about whom? The acceleration or velocity when they say moving parallel. Movement. When it comes to the movement, it's velocity who describes it. The direction, basically, the direction that your object travels is described by the velocity. Understood? So in that case, your velocity is what? Because velocity is also giving you the direction. Your velocity is what? Parallel to vector I. So when your velocity is parallel to vector I, you can see there's no j component. So you can use a shortcut here. What's the shortcut? The velocity is moving parallel to vector I. What do you say about the j component? J component should be directly 0. Okay, so you can either use that shortcut, or you could say, okay, velocity is parallel to vector I. This is what we do in M1. I mean, then velocity is 6 sine 3ti plus 1 plus 2 cos tj. To remove the parallel, you can put a equal and put a constant. Constant times I, and then compare coefficients. You don't even need to go this far. You could directly get the answer. Anyway, so if I compare the coefficients, I will not go for the I coefficient. I'll go for which one? The J one. Because I will, the coefficient of I will have an unknown value called K, which is, value that we put to remove the parallel sign. When you compare coefficients of J, 1 plus 2 cos t equals to what? This side there's 0J. Understood? You could do this immediately. Even without writing this middle step, you can write this down immediately. In the moment you see the object is moving parallel to y, it means your velocity j component is 0 because there's no j component for the velocity. And now solve this. This is now P2 trigonometry. So 2 cos t equals to, here plus 1 goes to the other side as minus 1, right? Which means cos t is equal to minus half. Cos t is equal to minus half. And they want the first value. Now, you know, normally when you have trigonometry, do you have just one solution? Now, you know, you have multiple solutions, but they want which one? They want the first one. They want the first one. So first one, you can directly type cos inverse, and when you type cos inverse and get the answer, you will get the very first answer. Or else you could go for the quadrants and do it. All silver teacups, and choose quadrants where cos is negative. All and cos, everyone is positive, sine and tan. And take the acute angle. Cos inverse half is how much? Cos inverse, not if you type minus half, you directly get the answer. Actually, you can do that. Cos inverse minus half will give us the direct answer. However, if you type just cos inverse half, and make sure this time your cal is in radian mode, because we are inputting the t value into these equations. And when you are inputting t values into the equations and finally find velocities and accelerations, it shouldn't be in degrees. Okay, so they expect you to understand, since t is a time and also t is an angle, t must be measured in what? T must be in radians. They don't even need to tell you that. Okay. How much is cos inverse? So directly, if you take cos inverse minus half, you get the full angle here. You get that obtuse angle 120. Or else if you type cos inverse half, you get, if you just type cos inverse half, you get 60, right? You get 60, which is pi over 3. And pi minus pi over 3, and it will give you the same amount as cos inverse minus half. 2 pi over 3. The angle we want is this 2 pi over 3. So the first value, there are more places, but we don't need those. So I have the t value. Now what do I need? So this is the first time when the particle is moving parallel to vector I. Okay, what do I need? So I have found the time when the particle is moving parallel to vector I. Now what? Are they asking us to find the time? Now they are asking us to find the position vector when it is moving parallel to I. So I have found the time when it's moving parallel to Y. If I want to find the position vector, what should I do? Take the velocity component and what? Integrate.
So why then is it not even considered diagonal? Like why just 2 pi over 3?
2 pi over 3 is the first angle. They have told us to take only the first one. Find the position vector of P relative to O when P is first moving parallel to the vector. So there are many other places where you move parallel to vector, because there are other places also where cos t becomes minus half. We have multiple solutions for it, but they want the first one. So that's why I took the first one. Then let's integrate. Start integrating. Okay, so velocity to position vector, we need to integrate velocity displacement. And when you have velocity in terms of I and j, in the integration gives you the position vector. So r equals to integration of 6 sine 3t gives you what? Sine integration is negative cos, right? Sine integration is minus 1 over k cos kx. So this is 6 times minus 1 over 3. Sine differentiation is cos 3t. Are you with me? I, and then inside the j. What happens when you integrate a 1? Now, you're integrating with respect to time. So when you integrate 1, you will get t. Cos t, when you integrate 2 times, cos t integration is directly sine t. Cos t integration is directly sine t. So r equal minus 2 cos 3t times I plus t plus 2 sine t times j. And don't forget what? After you're done with integration, you must put a plus c. The moment when you integrate and then you're done with integration, you must put a plus c. So to find this plus c, they have given us some conditions, right? At time 0. Time 0, the question vector is given as 4y minus root 3j. Input at time 0. R equals 4y minus root 3j. Is that correct? So input the value. The time is 0, right? 2 cos 0. This is 0 plus 2 sine 0. J. How much is it? 4i minus root 3j. Cos 0 is 1, right?
Yeah.
So basically I end up getting here minus 2i. 0 is 0, sine 0 is also 0, which means I just have plus c here. So my c value is 4i plus 2i, 6i minus root 3j. Are you with me? So let's input that into our R equation. R becomes equal to minus 2 cos 3t times I, t plus 2 sine t times j, plus the c value is 6i minus root 3j. Shall we input the I value inside the I bracket and the j value inside the j bracket? So when you input inside, you get here inside minus 2 cos 3t with the I and plus 6. Okay? And inside the other bracket, t plus 2 sine tj with minus root 3. So these are the components we get with j. Right? Okay, so then what are we supposed to, is this our final answer? Is this what we are supposed to find? I have found the position vector with respect to time at any given time. But this is not my final answer. What they want us to do is what? Find the position vector at the first time when you're moving parallel to vector I. So first time when we move parallel to vector I is when time is 2 pi over 3. So that's the first time you move parallel. So the position vector when time is 2 pi over 3. That's what they want you to find. First time when the object, the position vector, when it's moving parallel to the vector I. When it's moving parallel to vector I, the time is 2 pi over 3. So now get the position vector R equal minus 2 times 2 cos 3 into 2 pi over 3 plus 6i t is 2 pi over 3 plus 2 sine 2 pi over 3 minus root 3j. Now don't go type everything in the cal. Do it separately. Here 3 and 3 cancels. I end up getting here R equal minus 2 cos 2 pi. How much is cos 2 pi? Cos 2 pi is 1, right? Cos 360 is 1. Minus 2 into cos 2 pi is 1 plus 6i. And inside here you get 2 pi over 3 plus 2 times sine 2 pi over 3. So cal must be in radian mode, right? So sine 2 pi over 3 gives me root 3 over 2. So that into 2. Because it's 2 sine 2 pi over 3, right? It's 2 sine. So that gives me root 3, a positive root 3. And there's a outside, there's another negative root 3. Do you see 2 sine 2 pi over 3 is root 3. There's another root 3. Root 3 cancels. And then what's our position vector? R equal minus 2 plus 6 is 4i plus 2 pi over 3 j. So this is your position vector when the object is first moving parallel to the vector I. Two small balls A and B are moving in opposite directions along the same straight line on smooth horizontal ground. The mass of A is 2m and the mass of B is 3m. The balls collide directly. Immediately before the collision, the speed of A is 2u and the speed of B is u. The coefficient of restitution between A and B is E, where E is greater than 0. By modeling the balls as particles, show that the speed of B immediately after the collision is this. Okay. So 6 marks for this, right? Let's draw the diagram. So you have two particles, A and B. The mass of A is 2m and the mass of B is 3m. Immediately before the collision, they are moving in opposite directions, okay, along the same straight line. Immediately before the collision, the speed of A is 2u. So I'll move the before speeds, I'll mark it on top. and the speed of B is U. So they are moving in opposite directions, which means you have to mark it face to face. And since they collide, you have to mark it in this particular way, right? Then the coefficient of restitution A and B is E by modeling the, okay, immediately before the collision speeds are given, right? Okay. By modeling the balls as particles, show that the speed of B immediately. Okay. So this guy's speed. Okay, so how do we find this person's speed? The thing is, these two, the before impact speeds are given to you, after impact speeds are unknown. So we will use here two unknowns and the directions. So you'll have to find out, like, speculate the directions. Okay, so how do you like to speculate the directions? I can find out, see, like, this is 3M and U, this is 2M and 2U, maybe this is like a little bit slightly higher, right? So I feel like probably we should reverse this. In fact, you can speculate. So if you're wrong, you'll get a negative sign. Okay. So the velocity of V, because I notice here, I'm just taking the product. This is a 4mu, this is a 3mu. 4mu is bigger, right? Definitely bigger. So this I feel should turn back. Okay, so then this is my V1, or let's say this is the velocity B. And velocity A, you could think that it's going forward, or you could say it's coming back, like it might move forward or it might turn back. Okay. Okay. So we'll say that A is also, if we say A is going back, you can take anything actually. Velocity of A is entirely up to you. If you're wrong, you'll get a negative answer. That's all. Okay, so then let's say this is going back, velocity A. Okay, so I'm just speculating. I feel sure about velocity of B, however. So velocity of A, we can see whether we are correct or wrong. If you're wrong, you'll get negative. So that means the direction needs to be changed. Okay. So what are the rules we use here? The law of conservation of momentum and Newton's law of restitution. Let's use the law of conservation of momentum. So by the law of conservation of momentum, I will use the forward direction as positive. What do I get here? Initial momentum is equal to final momentum. So initial momentum, mass into velocity, 2m into 2u. The next one, 3m into plus u, but this is going backwards, right? So these are the two initial momentums. The other one, 2m into velocity A, which is going backwards, plus 3m into velocity B, which is going forward. So change the directions and fix everyone. This is 4mu positive. This is going to be minus 3mu. I'm changing the direction. This is going to be minus 2m into velocity A because I'm changing the direction. This is positive 3m into velocity B. So everyone has the letter M and I can remove it. You can remove it. 4u minus 3u is positive u. Minus 2 times velocity A plus 3 times velocity B. Is that okay? Okay, so then the next one, we had to use the law of restitution. So how does the restitution law work? E is equal to speed of separation divided by speed of approach. So speed of separation, here also choose a positive direction. I'll choose forward is positive. So separation. So shall I take VA minus VB? VA is backward, VB is forward. When you divide, you should switch and take. Do you remember in restitution? So if you take VA minus VB, when you're taking the speed of approach, switch and take it. So it will be the other way, starting with B now. U minus 2U. So this is how the law of restitution works. Speed of separation, whatever you put here, just put the minus mark in the middle, subtract two velocities, and in the bottom, switch the order, and you start with B. So velocity of B is U initially, minus velocity of A initially is 2U. And now what? Now fix the directions. When you fix the directions, what happens? So I want to switch everyone to the right side. So I get here minus velocity A. I get here minus velocity B. It's already minus. I need to fix it. This is U. It switches to the other side. Minus U, right? Minus 2U. I don't need to change. So I basically change these two guys. I changed this one and I changed this one. These are the two guys I changed. So I think you can see minus VA minus VB minus U minus 2U is minus 3U. Do you agree? And if I take a negative sign now, do you see that I can remove a negative sign from everyone? Or else let's say we have minus 3UE equal minus VA minus VB. I took the minus 3U. You could remove the negative sign at this step itself, or you could take it to the other step. Anything is fine. So I'll remove the negative sign now. 3U equal VA plus VB. So then I have my two simultaneous equations. Can you see? So this is equation number 1. Equation number 2. Solve the two equations. You can see all simultaneously and get the values for VA and VB. So when I solve it, let me make VA the subject. I'm trying to find the velocity of B, right? That's what they ask us to find. Show that the velocity of B. So let me make velocity A the subject. So velocity A is 3UE minus velocity B. Let's substitute. So U equal minus 2 times velocity A plus 3 times velocity B is inside brackets 3UE minus velocity of B. I substitute this value. Is that okay? So I get here U equal minus 2 times velocity A. 3 times 3 is 9UE minus 3 times velocity. Sorry. I have substitute for velocity of A. Sorry, pardon. Here, right? Substitute I get here, sorry. So U equal minus 2 times velocity of A is 3UE minus velocity of B plus 3 times the velocity of B. Is it correct now? I took the value of the velocity and substituted the first equation, okay? U equal minus 2 times velocity A is 3UE minus velocity B plus 3 times velocity B. Is that okay? So I get here U equal minus 6UE minus into minus is plus 2 times velocity B plus 3 times velocity B. Is this correct? So U plus 6UE 2 VB, 2 velocity B, 3 velocity B is 5 velocity B. So let me rearrange this nicely. So velocity B equal U plus 6UE over 5. I think I showed that was something with 1 over 5. And U was taken out, right? So taking U out, I get 1 plus 6E. U over 5. Is this to show that? 1 over 5U, yeah. U over 5 in other words is 1 over 5, right? So this is the velocity of B. This is clear. Okay, after the collision with ball A, ball B hits a smooth vertical wall which is perpendicular to the direction of motion of B. The coefficient of restitution between B and the wall is 5 over 7. Ball B rebounds from the wall and there is a second direct collision between A and B. Find the range of possible values of E. Okay, so what do we do here? Now they say here that the ball B goes and hits the wall. And we know the speed with which it hits the wall, right? It goes and hits with the velocity V that we found. Okay, and let's say the rebounding velocity, let's give it a new name. So let's give it as X. Give it as X. Okay. So then they have told you the E value is how much? 5 over 7. So can't you find the speed of rebounding from the wall? The speed that B rebounds? The speed B rebounds from wall. So we directly use the equation E equal V over U. This equation can directly be used, right? It has already taken into account the directions, and you are hitting a wall, if you're hitting a ground where one object is stationary. We use E equal V over U. So E equals V is the V is what I want to find. The final velocity is X. U is the velocity B. Velocity B we have already found, right? Okay. This is rebounds back definitely. Okay. VB is this way. Velocity. The X is rebounding back. Okay. So input the values here.
-1.
Okay. Just make sure that you do not confuse the E values. So here the E value that we have is different. Okay. From the previous E value. Okay, so this E value is between the restitution between the wall and this particular object. So this is 5/7. Okay, before you input the velocity B, so 5/7 into velocity B is equal to X. Input the velocity B. Velocity B answer we found, right? It was 1/5 U times 1 plus 6C. Do you agree with me? The 5 cancels out and we get 1/7 U times 1 plus 60. This is the X. The speed with which B rebounds from the wall. Okay, and in here, are we replacing the E value with 5/7? No, this E value was what you had the restitution between A and B, the objects, the two particles. So that is not replaced, only the E value was known only for the restitution between the wall and the object. Okay, right. So now to find, now they're saying there's another collision, right? They say there's a second direct collision. So shall we also find the velocity of A? Now we didn't find this yet, right? We didn't find this yet. So how can I find the velocity of A? Because to say that there's another collision, I need to compare the velocity of A and then see whether how they collide. Okay, so how can I get the velocity of A? Already we found the velocity B, right? Shall we input that into one of these equations and get velocity A? So input it into the equation. I have velocity A subjected. Shall we input? So velocity A equals 3UE minus velocity B. Input the value. Velocity B was 1/5U 1 plus 6C. Input the value. Minus 1/5U into 1 is minus 1/5U. Minus 1/5U into 6 is minus 1/5 into 6 is 6/5, right? 6/5 UE. So I can add the like terms. 3UE minus 6/5 U is 3 minus 6/5 is 9. 9/5 UE plus 1/5 U. Is this okay? Plus it's minus. Basically, I'll be taking the 1/5 and a U out. That gives me 9E minus 1. So this is the velocity of A. So I get velocity A is 1/5 U, 9E minus 1. Okay, so now this is our object A and it travels back in this velocity. So now they are saying ball B rebounds one from the wall and there is a second direct collision between A and B. So if there has to be a second direct collision between A and B, what is the requirement? What is the requirement for there to be a second direct collision? If you compare the X value and the velocity A value, for there to be again a collision, what do you say about the magnitudes of the X velocity and the this velocity of A? X should be greater than velocity of A. So that's how we find the range of possible values. So for a second collision, X should be greater than velocity of A. So X is, what was the X value? 1/7 U 1 plus 6C should be greater than velocity A is 1/5 U 9E minus 1. Simplify this and get the range. U and U cancels. 1 plus 6C, we'll multiply that with 5. This one with 7. So we get here 5 into 1 is 5. 5 times 6 is 30E. 7 times 9 is 63E minus 7. So I get here 7 plus 5 is, no. 12, right? 63E minus 30E. How much is it?
33.
Which means E is less than, right? 12 over 33. E less than 12 over 33, in other words, is 4 over 11. Yeah, so basically E is, the mouth is close towards E, right? E is less than 4 over 11. And does it mean like you have infinitely many values of E less than 4 over 11? No, you know, V has definitely a lower limit. What's the lower limit? No, the lower limit of E is 0, not minus 1. Okay? Yeah, and they have told you E is greater than 0. They have told you in the sum E is greater than 0.
Why cannot we be negative?
Okay? E, the range of E values are between 0 and 1. When E is 0, it's perfectly inelastic. And when E is 1, it's perfectly elastic. So anyway, your E values are going to be in between 0 and 4 over 11. A smooth solid hemisphere, okay, is fixed with its flat surface in contact with rough horizontal ground. The hemisphere has center O and radius 5A. A uniform rod AB of length 16A and weight W. Okay, it's a uniform rod. Okay, a uniform rod of length 16A and weight W rests in equilibrium on the hemisphere with end A on the ground. The rod rests on the hemisphere at the point C where AC is equal to 12A and angle CAO is equal to alpha as shown in figure 1. Points A, C, B and O all lie in the same vertical plane. Explain why AO equals 13A. Okay, so what do you notice here? This is a hemisphere. The rod is touching the hemisphere, right? So basically what does that mean? At this point, this is like a tangent. And you can understand that this is creating what? What do we have here? This is the radius, right? This is the radius of the hemisphere. And this is like a tangent. You definitely have a 90-degree here. So explain why AO is 13A. Basically what? Because why? Because ACO is a right angle. ACO is a right angle, and you can say AB is a tangent. AB is a tangent to the radius CO. Okay, let's say that. Part A, explain. AB is a tangent. We can see it, right? AB is a tangent, which means angle ACO is equal to 90 degrees. So you can use Pythagoras theorem. AO square is equal to AC square, or 12A square plus 5A square. So what do we get here? I get here AO square, I get 144A square plus 25A square, which gives me how much? 169A square is AO square, which means AO is how much? 13A. Just to explain, just one mark. Okay, it's just one mark. Okay, so part B, the normal reaction on the rod that C has magnitude KW. Show that K equal 8 over 13. Okay, look. Now the first thing is you need to mark your forces, right? Let's mark all the forces. What are the forces? Again, the smooth solid hemisphere is fixed with the flat surface in contact with the rough horizontal ground. So the hemisphere has center radius 5A, uniform rod AB, okay, length 16A, weight W. It's uniform means weight acts at the center, which means you will mark your weight W. Mark your weight W at what mark? This whole length is 16A, which means this length should be 8A, right? It's 8A on either side. Okay, then the rod rests on the hemisphere at the point C. So when the rod touches the point C, what do you expect to have at this point? You have what? There's a normal reaction, right? There's a normal reaction. Whenever there's a contact force, there's a normal reaction. And they have said the normal reaction at C has magnitude what? KW. So they have told the normal reaction here is KW. And when you mark normal reaction, the rule is what? Normal reaction always acts perpendicular to the surface that we are touching. So rod is the rod is what is touching the hemisphere. So rod touches the hemisphere. So at that point, to the hemisphere, you must draw a perpendicular. So this is the KW. So this is the normal reaction KW. Is that okay? And then what else do we have? And then the other end, okay, with end A on the ground. So if your end A is on the ground, what do you have? Once again, it's a rough ground, right? It's a rough horizontal ground. So when you're touching the rough ground, what do you have? Definitely, that's friction. So obviously, this rod will try to slip this way. The rod will try to slip down in this way. So the friction is holding it back to the other side. And you have normal reaction. Let's say the normal reaction is N. Let me mark it as N at this point. Okay, so we have friction and normal reaction. Is that okay? So these are all the forces. First thing is to mark all your forces. They are asking you to show the K is 8/13. So in this particular lesson, when you want to show something like this, there are only three things to do. What is it? You take the equilibrium of forces along the plane and perpendicular to the plane, and you can take moments. So to show KW is K is 8/13, what's the best strategy to use here? We will use moments, and moments about which point? Moments about A. And remember, in here our rod is the most important person. Like, we are not marking any forces for the hemisphere. We are primarily concerned about the rod. So we have marked every single force acting on the rod. Okay, no one else. We are concerned about every force acting on the rod, right? So let's apply moments around A. So you can understand it's moments around A is what I should consider, right? Because then when you take moments around A, two forces are automatically we can neglect, we can remove. So then we need to be only bothered with W and KW. Okay, so with W, can I know what kind of a moment W creates? So when you take moments around A, W creates a clockwise moment or anti-clockwise moment. So you can see W is pulling down, right? So around A, you can see W pulls down, which means it gives a what moment? Anti-clockwise moment. So anti-clockwise, shall I put negative? Minus W into, what's the perpendicular distance from A to the line of action of W? So this is the line of action of W. So from from point A to the line of action of W, what's the perpendicular distance? Do you see? Sorry, it's clockwise. I'm sorry, this is clockwise, right? From A, when W which pulls down, it's clockwise. Yeah. So what do we have here? How much is this distance? This is going to be 8A cos alpha. Do you agree with me? It's 8A cos alpha. So W into 8A cos alpha. Okay. And then the other force I had considered is KW. So I think we can see KW already makes 90° with the line of with the AB line. So do I need to resolve KW when I'm taking moments around A? No, right? You can see I directly have the perpendicular distance to KW. Right? It's directed 12A. KW gives me a clockwise moment or an anti-clockwise moment. Yeah, it's pulling backwards. So this is giving an anti-clockwise moment around A. So then I'll write it as minus KW into distance is 12A. The system is in equilibrium. Therefore, the sum of moments must be equal to 0. Okay, then let's simplify and get the K value. So cos alpha has, yeah, we can get the value of cos alpha here, right? So we have a right angle triangle and we can get the values of sine, cos, tan alpha. So what's the cos alpha value? Considering the right angle triangle, do you see we have a right angle triangle here? The alpha, the 90, so this is 12A, 5A, 13A. So what is cos alpha? Cos alpha is adjacent over hypotenuse, which is adjacent is 12A over 13A, A to A cancels and you get 12 over 13. Sine alpha is? No need sine alpha. Yeah, we don't need sine alpha, we just need cos alpha. Okay, it's 12 over 13. Now let me write it down here. So let's work on this. So W into 8A cos alpha equals KW times 12A. So A is cancelled out. Even W will be cancelled out. Do you agree with me? So 8 times cos alpha is 12 over 13. K times 12. Even 12 will cancel out. Do you see 12 will remove with the other 12. 12 goes as a division, it removes. So K equals to 8 over 13. Which is to show that. Okay, so here the 13 came because we found AO is 13, okay, in an event. If you see here, AO is 13A, which we found, that's how this became 13, okay, 13A. Let's move on to part C. The resultant force acting on the rod at A. The resultant force means what? at point A, we have the normal reaction at A and the friction force. So when these two guys get together, it creates a resultant force. So the resultant force that acts on the rod at point A has magnitude R and acts upward at angle theta degree to the horizontal. So mark it at that point at A. Let's mark the resultant. So I'll mark the resultant somewhere like over here. Is this okay? With two arrows, this is my resultant. And the resultant makes an angle theta degree with the horizontal. Do you see? The resultant makes an angle theta to the horizontal. Okay. So now they are asking you to find an expression for R in terms of W. Okay. You have to find R in terms of W. So to find R, what do we need? To find R, what do I need? Obviously, I need the X component and the Y component here, because when I take the square and square root of this X and Y component, I can find R. So the first thing we need to do here is what? Find the value of N and find the value of F. So how do we find that? We need to resolve, isn't it? We need to resolve here. So now I already did moments. So in part C, what I need to do is I have to consider the horizontal equilibrium and the vertical equilibrium. So shall we resolve? So KW needs to be resolved. Let's resolve KW. How can I resolve KW? So let me mark the horizontal and vertical forces. So how I need an angle to resolve, isn't it? How do I get this angle? Now you can see this angle alpha. It comes over here as a alternate angle. Do you agree? It comes over here as an alternative angle. Do you agree? And also, do you see that this is KW and the line AB is perpendicular? So therefore, if this is alpha, do you see that this should be 90 minus alpha? That this angle should be 90 minus alpha. And then once again, what happens? This line, this one, and again the horizontal, and this is a vertical, which means we have a 90 degree here again, which means the small angle becomes alpha here. Is that clear? The geometry. This alpha comes here as vertically opposite. Then this is because it's perpendicular between KW and AB. This is 90. Then this particular angle here that I have marked is 90 minus alpha. Then again the vertical and horizontal are perpendicular. So 90 minus alpha gives me alpha here again. Okay, so now that's all I need. Now I need to just mark the components. So KW, when I resolve to the vertical side, I get what? KW towards the angle, I get cos alpha. And this one I get KW sin alpha. So now I don't need to work with the green color one. I have the two resolved components. So let's take the horizontal and vertical equilibrium. So if I take the vertical equilibrium, let's take vertical equilibrium, what do I get? When I consider vertical equilibrium, what do I have? What are the forces I have to the vertical side? KW cos alpha is upward, right? KW cos alpha upward. Who else is upwards? Plus N. And to balance it out, we have what? The W. So you can say it's directly minus W, or you can say directly equal W, or you can say minus W equals 0. Okay. So cos alpha is found. Let's input that value. K value is also found, right? K value was found previously as 8 over 13. W cos alpha is 12 over 13 plus N. So I can find the N value here. Simplify. Can I know the answer? N equal W minus 8 times 12 over 13 times 13W. How much is N? 1 minus. Simplify. How much do I get? 73 over 169. So type it in the cal. 1, you type in the cal as 1 minus 8 times 12 over 13 times 13. And your N is now 73 over 169. Okay, similarly use horizontal equilibrium. Go for the horizontal equilibrium. And what do we have here in the horizontal equilibrium? What are the forces we need to consider? KW sin alpha is equal to what? Is equal to the friction. So actually I need the sin alpha, right? I do need the sin alpha. Using this triangle, get sin alpha. So when I use this triangle and it's find sine alpha, what is sine alpha? Sine alpha opposite over adjacent, 5a over 12, opposite over hypotenuse. 5a over 12a is 5 over 12. Do you agree with me? So input the value sine alpha is 5 over 12. K value was found as what? K value was found as 8 over 13. 8 over 13 into W into sine alpha is 5 over 12. Get me the friction value. What is the friction? Get me the F value. How much is it? Eight over 13 into 5 over 12 is 10 over 39. Yes. 10 over 39 W. Check this answer again. The sine alpha, there's a, okay, sine alpha is 5 over 13, right? Opposite over a hypotenuse. Opposite over hypotenuse is 13, so it's 5 over 13, which gives me what here? Sine alpha is 5 over 13, which gives me 40 over 169. 40 over 169. Yeah, this is the F value. Okay, so then we have found our N values and the F friction value. Okay, so just be careful here. So there was a slight error here. It should be 5 over 13, not 5 over 12. Okay, because sine is opposite over hypotenuse. Okay, I had used tan alpha. Okay, so then I fixed the mistake here. So now let's move on. They're asking us to find R. So how do I find the resultant? To find the resultant, we take the horizontal component, square it, add it with the square of the vertical component, and then we square root it. That's how we find the resultant, isn't it? So resultant R is equal to, the resultant R is equal to the N value square plus the friction value square root. Input the values. N is 73 over 169. W square plus friction is 40 over 169 W. How much is R? Root 41 over 13. Yeah, it's a matter of typing it in the cal and taking the answer. And you can see here W square is there, right, in both these cases. So it's a square. You can take the W outside of the root and work with this. Okay, 73 over 169 square plus 40 over 169 square. Like basically both of them have W square, so the square can come out of the bracket as a normal W, which gives us how much? This value in the cal gives us root 41 over 13, and there's W here, right? So R, so this is the R value. R is root 41 over 13 into W. Okay, then next part, find the value of theta. How do we find the theta value? How do I find this theta value? So this is similar to what we do in projectiles. Okay, so what do we do here? When the two, so you have here N, because it's not clear, I'm just drawing it again. The resultant, so to find theta, we use directly tan theta is equal to what? Opposite of adjacent. In this case, the opposite will be the N, the force N, adjacent will be the F. So how much was our N value? Remind me again, how much was our N value? How much was our N value? The N value was 73 over 169, right? N value was 73 over 169 W. Divided by what was our F value? 40 over 169, right? So you can definitely understand W to W should cancel out. Type in the cal 70 over 169 divided by 40 over 169. So it's a matter of typing. 70 over 169. You could just give the normal division also. 40 over 169. You can do it from your, you don't need to type like this. You could just give the normal division mark and do it. 70 over 169 divide by 40 over 169 gives us 7 over 4. So tan theta is 7 over 4. Take tan inverse and they want the answer theta. We can give it to the nearest degree. They want the nearest degree. Okay, we can give it to 3SF. How much is it? Tan inverse 7 over 4 is 61 point. Okay, 61.2796. 61.27967. When I correct it to 3SF, it's 61.3. You can give it to 3SF. They have not asked for a significance. 73. Oh yeah. Okay, sorry. 73 over 40. This 73 over. Okay, so 73 over 40. And tan inverse of 73 over 40 is 61.3 degree. Yes. Okay. Moving on to question number 6. Uniform wire is used to form the framework shown in figure 2. So this is what? This is a framework. In the framework, ABC is straight and has length 25A. Okay, so the length of ABC is 25A. Are you with me? And ADE is straight and has length 24A. ABD is a semicircular of radius 7A. EC is 7A. Okay, they are saying the points AEC is 90. Okay, AEC is a 90 here. Okay, so this is a 90 degree here. And then the points A, B, C, D, and E all lie in the same plane. The distance of the center of mass of the framework from AE, from this line, the distance of the center of mass of the framework is D. Show that. Okay, you have to show that D is equal to this. Okay. So how do we do deal with center of mass in a framework? In frameworks, we say the mass is proportional to what? The length. So what you do is you have to take the mass of each and every individual wire here and take the center of mass of each and every individual wire. So to do this, the first thing is you have to mark a 0, 0 point because we need to mark coordinates. So which one do you prefer to mark 0, 0? You can mark A as 0, 0. Okay, or you could even mark D as 0, 0, or even you could mark E. Okay, so it doesn't matter what you choose, just that whatever you choose, show it properly. If you choose A, everything will be below A. Everything will be below A, and we can say the below, even though, I mean, we don't need to mark specifically negative for the below ones because everyone is below A. Is that okay? Then shall we mark 0, 0 at A? If you are comfortable, you can mark 0, 0 at E. It's entirely up to you. Okay, so here, since my whole diagram is below A, I can mark the 0, 0 at point A and like consider the downward distances without marking them negative. I could mark them positive. Okay, now let's take each and every single wire. So the first wire that I'm considering is the wire AE. Shall we mark the coordinates? So what is the coordinate E? Because I need these coordinates. E coordinate is 24A below, right? So the x coordinate should be, since it's on the same vertical line, x is 0. And y should be, shall I mark 24A instead of marking minus 24A? Because it's everything is below. And the coordinate at point C, what's the coordinate at point C? The x coordinate is, can you see it's 7A, right? This is 7A, comma, the y coordinate is 24A. I'll mark everything positive. The positive is below. The radius is given to you. They have told the radius is 7A, right? The radius of this semicircle is 7A. Okay, so I have marked most of my crucial coordinates. And what about the center? The center coordinates of the semicircle? The coordinate is x coordinate is 0, y coordinate is 7A. Is that okay? Right. So now I have most of my major coordinates. Now it's time to take the mass and the mass and the center of mass. Okay. So in a wire, the mass is proportional to what? The length. Okay. Let's start with the AD wire. So not the AD. We'll directly take the AE wire. So in the AE wire, what is the mass?
24.
Okay. So we'll take mass center of object mass, center of mass, or we'll say the wire. The wire, the mass ratio, basically because we have the mass ratio here, and then the center of mass. The first wire that I'll be considering here is the AE wire. In the AE wire, the length of the AE wire is 24A. Okay, so it's 24. My mass ratio is 24A. Okay, you could cut off the A at the end. Okay, we'll just leave it like this, 24A. And then center of mass of the wire is in the middle of it, right? So what's the middle of 0, 0 and 0, 24A? 0, 12A, because you can add and divide by 2 the two coordinates. 0, x coordinate is 0, y coordinate is 12A. Agreed? Add and divide by 2. Okay, next let's take the wire AC. In the AC wire, what is the length? The mass is given as, the length is given as 25, right? ABC is straight and it has length 25A. So let me mark 25A. That's the mass ratio. Center of mass, add the two coordinates and divide by 2. 0 and 7A. Add and divide by 2, it gives me 0, 7A. When you add and divide by 2, it gives me 3.5A or 7/2A. The other one 0 and 24A. When I add and divide by 2, I get 12A. Do you agree with it? Then the next one. So I have taken the AE wire, the AC wire. Who else is remaining? The semicircle, right? The ABD semicircle. The semicircle ABD. So at the top, they have given you some clues here. The center of mass of a semicircular arc of radius r is 2r over pi from the center. So they've given you the equation, actually. So we can use it. Okay, by the way, what's our mass ratio? Now you know the mass ratio, we consider the length. So what's the length of a semicircle? The circumference of half of a circle, right? So 2 pi r, we will be taking half of 2 pi r. Are you with me? 2 pi r is the full circumference, so half of 2 pi r. What's the radius? The radius is 2 pi r. Radius is 7a. So basically the 2 to 2 cancels and I get 7 pi a is the mass ratio. Center of mass. How do I get the center of mass? So if you have a semicircle, now I only have this, I'm only taking the semicircular arc. Okay, so the center of mass of the semicircular arc comes along what? Comes along its axis of symmetry. Are you aware of it? The center of mass of the semicircular arc will come along its axis of symmetry, which means at this point that I mark the center. Okay, so at the center of the, let's say the center is x, so it comes along the axis x. Okay, so then along the axis x, the distance is how much? 2r over pi. 2r over pi is the distance where you get the center of mass of the semicircular arc. So then what about, so that gives me only the x coordinate. So the 2r over pi should give me the x coordinate. Do you get what I'm trying to tell you? 2r over pi is this xg, the x distance along the line of the axis of the line of symmetry of the semicircular arc. Okay, so how much is 2r over pi? Radius is 7a, right? So how much is it? This gives me 2 into r is 7a, right? 2r over pi, that is the x distance. What about the y distance? At point x, at this point G, what about the y distance from A? From A, what is the y distance? Your y distance is directly down how much? 7a, right? Your y distance is directly down 7a. Do you see? Okay. Then finally, I think we have taken all y's into consideration. Am I correct? So finally, add everyone and take the total mass. So let's take the total mass, the framework, the total framework. The total framework, if I got to get the mass, I have to add all these, right? 24A, 25A and 7 pi A. 24 plus 25 is 49A, right? 49A plus 7 pi A. I think that's the best we can do at this point. And then the center of mass coordinates are x bar, y bar. Are you with me? Okay, now let's use, they're asking us to find the value of D, and they have said D is the distance of the center of mass of the framework from AE. Do you think this D represents the X bar here or the Y bar here? D is the distance of the center of mass of this entire framework from AE. Now this entire framework, let's say the center of mass is somewhere, let's say it's somewhere over here. So then what is D then? The center of mass of the entire, they say D is the distance of the center of mass from the point AE, which means what? From the AE line, which means D is the horizontal distance, which means D must be X bar, which means the show that you are trying to do for D is the X bar. So once again, from the line, they say the center of mass of the framework from AE. So AE is this line, and your center of mass is somewhere over here. The distance from AE to the center of mass is definitely the X bar. So the D is actually the X bar in the current what I marked here. So to get the show that all I have to do is to find my X bar. So everything is adding, we just add everything to the framework. So the moments must be added, right? Mass and center of mass, let's add it. So first one, I'll take only the X coordinates because I want to get the show that for the X bar. The D is the X bar. Take only the X coordinates. So 24A multiplied by 0 plus 25A multiplied by 3.5A plus 7 pi A multiplied by 2 into 7A over pi. You see? Is equal to 49A plus 7 pi A into X bar. Do you agree with me? Let's simplify. 24A into 0 is a 0. And 25 into 3.5 is how much?
175 divided by 2.
175 over 2A square. Here the pi to pi will cancel, right? And what do you get here? 7 into 2 into 7? 7 into 2 into 7 is 98A square. From here also, I can take a out actually. So I can take a 7A out, but we'll keep it like this for the moment. And you can see we can remove a out, right? We can remove 1A from the whole equation. Just remove 1A. Add these to 175 over 2 plus 98. 175 over 2 plus 98 is?
371 divided by 2.
371 over 2 equal 49 plus 7 pi times X bar. Let's bring the 49 plus 7 pi down.
Yes. 371 divided by 2. That's A, right?
There's a A. No, yeah, there's a A here. Yeah, there's a A remaining, right? Yes. 371A. This is 2 times 49 plus 7 pi. Is this okay? Now what do we do? Bring the common thing out. What can I take off from 49 plus 7 pi? I can take out a 7, right? 2 into 7. Do you agree? So 371 over 7 will simplify, right? Can you simplify 371 and 7? Simplify. 371 divided by 7 gives me 53. And you see we get the 53 on top. 371 and the 7 cancels. So 353A over 2 times. I took the 7 out. I'm sorry. This should be, when I take the 7 out, this should be 7 times 7 is 49 plus 7 times 5. I take the 7 out. So I end up getting here 2 times. This is 7 plus 5 equals X bar. I hope this is clear. Okay, so I took the 7 out here. And this should be 7 plus 5 and I get the show then. Okay, moving on to part B. The framework is freely suspended from A and hangs in equilibrium with AC at an angle alpha to the downward vertical. Find the value of alpha. Okay, you can see it's 7 marks. So it's quite large. Okay, so what do we need to do here? The framework is freely suspended from A and hangs in equilibrium with AC at an angle alpha to the downward vertical. So not AE but AC. They are saying you to find the angle between AC and the downward vertical. Okay, so I have just randomly marked this point G here. I did not find it. Okay, so let's just find it in a place where it's easier for us. Let's place it in a place like this. Let me make it bigger. Okay, anyway, so G is somewhere on this, okay? Somewhere. I'm just randomly placing the G. So when you hang from A, what is the theory when you hang? The place where you hang and the center of mass of this entire object becomes what? The hanging point and the center of mass of this whole figure, it becomes the line that you join. When you join the line connecting these two, that line becomes what? This line becomes your downward vertical. So I'm not sure whether this G comes in here or whether it comes out here. So we'll have to calculate the magnitude of the angles and we'll decide that. Okay, so we'll calculate the angles and decide this. So at this point, let's just say something like this. So they are saying the angle between what? The angle between AC, the framework is freely suspended from A and hangs in equilibrium with AC at angle alpha to the downward vertical. So AC. So AC makes an angle alpha to the downward vertical. Do you see? So AC makes an angle alpha to the downward vertical and they want you to find alpha. Okay. Okay. So before we find alpha, let's do a few things that we can do first. So I already found the X bar distance, right? We just found the X bar distance. The distance D was a X bar, right? Are you with me? So what I'm going to do is I'm going to find this big angle first. Let's say this big angle is theta, the angle between. I'm going to first find the angle between AD and the downward vertical. That means I'm going to find the angle between AD and AG. Do you see that I can create a right angle triangle here because I have the X bar distance here. Can't I find the Y bar distance? Can't I find the Y bar distance? I can, right? Let me erase all of this. Okay, so the Y bar distance gives me this particular distance, right? So using the X bar and Y bar, can't I find this theta angle? I can, right? So that gives me the angle between AE and the downward vertical. Do you agree with me? Shall we first find the angle between AE and the downward vertical? Okay, so I'm not, once again, I have to tell you, I'm not sure about the question of G. I just randomly mark it. It might come inside. If it comes in, then I will erase this line and mark G in. So we can, when we calculate angles, we'll be able to understand whether this is in or out. Okay, let's see how I understand it. First things first. To find theta, what's the first thing I need to do? I have found X bar. I must find Y bar. Let's find Y bar first. So go back to this table. So in this table, you can see I have already prepared the Y coordinates as well, right? So can't we find our Y bar? We can. Let's find our Y bar. Go to this table. This is now part B. 7 marks for part B, which means it's going to be a big task. So let's do it. The mass 24A into 12A plus 25A into 12A. I'm getting all the Y coordinates plus 7 pi A into 7A equals to what? 49A plus 7 pi A into Y bar. Do you agree with my working? Can you all simplify? I think I can remove a from everyone. Shall I remove a from every person? Okay, then let's multiply 24 times 12 is, give me the answers quickly. 24 times 12? 288A. 25 times 12? 300A. 7 pi into 7A is 49 pi A. From this one, shall I take a 7 out? Like it would have been easier to take the 7 out. And I get here 7 plus pi times Y bar. Do you agree with me? Okay, let's add 288 plus 300 gives me how much? 588A plus 49 pi A over 7 times 7 plus pi equal Y bar. Is there any chance that I can take 7 out? Just check. Yeah. Take 7 out then from the top. 84 plus 7. 84A plus 7 pi. 7 pi A. Then you can see I can definitely cut off So 7 to 7. Right? So is there anything else from 84? 84 also I can take a 7 out. Take 7 out. Take a 7 and a out. 84 divided by 7 is? 84 divided by 7 is? 12. So yeah, I took the A out. So 12. The 7 and A goes, so you get 5 here. Over 7 plus 5 equals to y bar. Do you agree with my x bar, y bar coordinates? Okay, then shall we find, now I have my y bar, I've already found the x bar. Shall we find the angle between AE and the vertical? That is the angle theta. Okay, so let's find the angle between AE and the downward vertical. Let me bring this angle, let me move the diagram. So I have now my x bar and y bar are both found. So I'm going to find the angle between what? I'm going to find the angle between AE and downward vertical. So the angle between AE and downward vertical, which is the theta. According to the diagram, I have marked theta. Do you see? So how do I mark? What do I use here? I use tan theta. Tan theta opposite over adjacent. Who is opposite? X bar, right? Yeah. X bar over the Y bar. Can I know the X bar value? The X bar value which we found earlier was 53A over 2 times 7 plus 5. This was to show that. This should be divided by, shall I write like this? This should be divided by 7A times 12 plus 5 over 7 plus 5. Do you agree with the way I'm writing? Instead of writing the division down, I wrote it with this sign. It's easier for us to cut, right? So again, 53A over 2 times 7 plus 5 times 7 plus 5 over 7A times 12 plus 5. So I think you can see here the A to A will cancel. The 7 plus 5 to 7 plus 5 will cancel. So what's the tan theta ratio? 53 over 7. No, that doesn't simplify. So I get 53 over 2 times 7 is 14 times 12 plus 5. Are you with me? Then shall we find the angle here? Let's get the angle. How much is the tan inverse 53 over 14 plus 14 12 plus 5? So with the Kelvin degree mode. So with the Kelvin degree mode, tan inverse 53 over 14 times 12 plus 5. Okay, so that gives me how much? I get 14.037. Okay, I get 14.037. Let's write a few extra digits. 40.037369. Okay, so that's the angle theta. So your alpha is in degrees here. That's why I did this sum in degree mode. Okay, so you might be having the question, can't we do this in radians? Okay, so we need to do it in degrees because the question says alpha degrees. Okay, I found theta. Now what? Now what? Now the thing is, shall we find the angle that we create? Now I want to find the value of alpha, right? So to get this alpha value, what if I calculate this angle? Let's say this angle between, let's say this angle is beta. The angle between AE and AC. How do I get the angle between AE and AC? So I think you can see we directly have AEC is a right angle triangle, right? So I can definitely get tan beta by using that, and then depending on that I can subtract theta and beta and get alpha. But first let's see whether beta is actually smaller than theta or not. Okay, so what do we get here? Tan beta opposite over adjacent, opposite is 7A over 24A. Tan inverse, get me the answer. So A to A cancels. Tan inverse 7 over 24 gives me how much? 16.205. Okay, so what do you notice here now? With your theta and beta value. So this is the tan theta value, right? So what do you notice here? So I think you can see my diagram is slightly off, right? My diagram is slightly off, meaning is the G coming outside here? No, G is supposed to come inside. Okay, the G is supposed to come inside. So when I fix it, let me redo the diagram. So when I redo the diagram, let me draw it and show it to you all. So this is the diagram that I redrew again with G in the middle instead of G outside, because the angle that we created with AEC, in the AEC triangle, our beta was something with 16, right? And the theta was something with 14. Am I correct? So because of that, we can definitely see theta is smaller than beta, which means this G has to be index. Bar Y bar is in here. So the question is to find the angle between AC and the vertical, downward vertical. That angle is alpha. How do I get alpha now? Alpha is equal to what? The beta angle, you have to subtract from the theta angle. So beta minus theta is equal to the alpha value. So let's get the alpha value. So alpha is equal to beta minus theta. So beta is 16.260205, subtracting with 14.037369. How much is alpha? 2.2232. So 3SF 2.22 degrees. Have they told us to give the answer 2SF or 3SF? Have they told? No, they've not told. So then find the value of alpha. So this is it. This is my value of alpha. Okay. Okay, question number 7. A particle P is projected from a fixed point O on horizontal ground. The particle is projected with speed U at an angle alpha above the horizontal. At the instant when the horizontal distance of P from O is X, the vertical distance of P above the ground is Y. Okay, so draw the diagram. So basically you have a projectile, and at a path along its projectile, okay, the particle is projected with a speed U with an angle alpha to the horizontal fixed point O. Okay. At the instant when the horizontal distance of P from O, the horizontal distance is X and the vertical distance is Y. Basically, this is like the coordinate X comma Y, the distance. This is the Y coordinate and this is the X distance. X distance is X, the distance. Okay. They are asking the motion of P is modeled as that of a particle moving freely under gravity. Show that Y equal X tan alpha minus Gx square over 2U square times 1 plus tan square alpha. Okay, this is something that you've done in your textbook as well, right? So that this is just a standard method of doing it. We use what? S equals ut plus half AD square horizontally and vertically. That's it. So first let's apply S equal ut horizontally. When I do horizontally, I don't need to put the half AD square because there is no horizontal acceleration. So the horizontal displacement is X. What is U? When you resolve, what do we get for U? We know we get U cos alpha. Vertical will be U sin alpha. So this is going to be U cos alpha into time is T. Are you with me? So I'll make T the subject because as you can see, X is there in the show that, U is there in the show that, alpha is there in the show that. So let me make T the subject, T equal X over U cos alpha. Are you okay with it? The next equation we apply S equal ut plus half AT square. I'm going to apply it vertically and I'll apply it vertically up because my displacement is upwards. So from O to P, the displacement upwards is directly what? The upward displacement is Y. Do you agree with me? U is initial vertical component of velocity is U sin alpha into T, and this is going to be what? Is it a plus acceleration? You know, you are moving freely under gravity. Yeah, you are imposed that the object is moving under the gravitational acceleration. So this is moving up. I put the equation up. Therefore, the A value should be negative G, right? It should be negative G. So I'll just put the minus in front. Minus half GT square. Are you with me? Replace the T value. We found T is X over U cos alpha. So U sin alpha into T is x over u cos alpha minus half into g into t square is x square over u square cos square alpha. Like I directly squared everything. Is it okay? T square means you square the whole thing. So x gets the square, u gets the square, cos alpha gets the square. Okay, so I get here y equal the u and u cancels. And I end up getting here what? Sine over cos is tan. So can you see I end up getting here x tan alpha minus here, I get here gx square over 2u square cos square alpha. G and x square multiplies, 2 and u square multiplies. Okay, so we are not done with the show that yet. I have got half of it. I just need to get gx square 2u square into 1 plus tan square. So what do we do for this one? We take the cos square up. You remember the rule, 1 over cos is sec. 1 over cos is sec alpha. So this is gx square over 2u square cos square. 1 over cos square is the reciprocal of sec. So sec square alpha. And the final identity we have is 1 plus tan square alpha is equal to sec square alpha, right? This is the last equation that we need to use. So y equal x tan alpha minus gx square over 2u square sec square alpha is 1 plus tan square alpha. And the 6 marks show that. It's quite easy to get it. A small ball is projected from the fixed point O on horizontal ground. The ball is projected with speed 20 meters per second at an angle theta degree above the horizontal. Okay. The vertical pole AB of height 2 meters stands on the ground with OA 10 meters as shown in figure 3. The ball is modeled as a particle moving freely under gravity and the pole is modeled as a rod. The path of the ball lies in the vertical plane containing OAB. Using the model, find the range of values of theta for which the ball will pass over the pole. Now look at this. Now, obviously to do this for 3 marks, you need to realize, number one, we definitely need to use the help of what? Part A. Okay, otherwise we can't comprehend this for 3 marks. Now in part A, I think you can see that we kind of have this kind of model, right? So this is like the AB is like this point here. So XY, looks like I already have my XY values. X is 10, Y is 2 and including my U value is how much? U value is 20. The alpha has become theta, still an unknown. Okay, however, they say they want the ball to pass above the wall, right? If they want the ball to pass over the pole, is y equal to or is y going to be what? If the ball needs to pass above this, y needs to be greater than 2. Then it passes over the wall. Are you with me? So when I come to part B, what are the requirements? First thing is I know x has to be 10, definitely. When x is 10, my y value needs to be bigger than 2. Do you agree with me? And also what else have they given us? The u value is given as what? 20 meters per second. The theta, the alpha value has become theta. Previously a question was alpha, now it's become theta and you are supposed to find the range of values of theta. Is that okay? Let's input the equation. So we have the equation y equal x tan alpha. X is 10 and theta, alpha is theta now, g into 10 square over 2 times u square is 20 square. Do you agree with my working? 1 plus tan square alpha is tan square theta. I replace all the values. X is replaced by 10. Okay, and the u is replaced by 20. Yeah. Let's fix this equation. I think you can see we end up getting the quadratic equation. Do you see? Let's get it y equal. I'll input the y value at the end because y needs to be bigger than 2. Let's get it. 10 tan theta. Can you all fix the value here? 10 square over 2 into 20 square. How much is it? 10 square over 2 into 20 square gives me 1 over 8. 1 over 8, I didn't input the g value. So 1 over 8 g into 1 plus tan square theta. So what do we get here? y equal to n tan theta, open the bracket, minus 1 over 8g minus 1 over 8g tan square theta. Is okay. So simplifying, so this is the equation, minus 1 over 8g tan square theta plus 10 tan theta minus 1 over 8g. This is my y value. And what do we need this y value to be? This is my y value, and y needs to be, this is y, right? This whole thing is y. Y needs to be greater than 2. Do you agree with me? Y needs to be greater than 2. Okay, so let's take, now this is a quadratic equation. Basically, you can see tan square is like the x square, tan is like the x, okay? So shall I take everything to the side and keep the x square person positive? So then I'll put 0 here and I'll take this here, 1 over 8g tan square theta plus 10 becomes minus 10 tan theta minus 1 over 8g becomes plus 1 over 8g, and there's a plus 2. Don't forget this plus 2. Okay, so now this is a quadratic equation. Type ABC in the calculator, the ABC, and get the two values. This is actually a quadratic minimum graph. Do you agree with me? Tan square is like x square, 1 over 8g is a positive, your A value is positive here. Do you notice? So it's a quadratic minimum graph, and what do we need? We need the plane, we need the set of values, we need the set of theta values where this expression is less than 0. As the expression is less than 0. So basically I need to, I am going to, obviously, you know, I'm going to get two roots here. What are the two roots? Let's get the roots. So let's get the two roots. It is 2. Okay, so this is the x square 1 over 8, or this I think doesn't give 1 over 8. We'll type directly g over 8, right? So g is 9.8 divided by 8. Do you agree it's a value? 9.8 divided by 8. The other one is minus 10. And the other guy is 1 over 8g plus 2, or 9.8 divided by 8. Okay, g is 9.8 divided by 8 plus 2. Do you agree with it? The calculator will give the priority for the division over the addition. And then we get the ABC values. Is this okay? So let's type the values. What are the values we get here? I get here for tan theta, one value is, how much is it? 7.8269. 7.8269. And the other value is, tan theta is 0.33635. So these are my two tan theta values, and there is a tan theta minimum graph, the x square. The x values is the minimum graph, and we need this to be less than, right? It needs to be less than 0. So basically I need to choose the values that are making this graph negative. Are you with me? So the two values I have here, 0.336359, and the other one is 7.8269. Are you with me? So what are the theta? I mean, where does tan theta fall here? Tan theta falls in between. So I want the range where it's negative, right? Which means I want this down part, which means tan theta will be in between 0.336359, and this is 7.8269. Can I have another extra decimal here? Yeah, so 0.6. Okay, the next one. Okay, then the next thing is, so this is the range of theta values, but not the theta values, this is the range of tan theta values, and I now need to make it to theta values. Can you all convert it to theta values? Tan inverse. Make it tan inverse. Tan inverse 0. So tan inverse 0.336359 gives me 18.59. So we need to keep it to 3 SF, so 18.6. And the other one, tan inverse 7.8269 6906. 82.7. So these are the range of theta. These are the range of values for your theta, where the ball will go above the wall. Okay. Then the next part. Let's move on to the next part. The next one. Given that theta equals 40 and that the ball first hits the ground at the point C, find the speed of the ball at the instant it passes over the pole. Okay, so then you can see here theta value is 40, and you saw for the range of values for theta to pass over the pole was how much? Theta between 18.6 and 82.7. So our theta is definitely in that range. Okay, so here the theta value is 40. Now it passes over the pole. So it doesn't mean it's like slightly going on from here, right? It will pass probably well above the pole. Do you get me? So in that case, we need to first find what? We have to find the y value at this point. Shall we find the y value? Because we already have an equation. So let's use the equation. Y equals, tell me the equation, y equals x tan alpha minus gx square over 2u square times what? 1 plus tan square alpha. Let's input our alpha value is now 40. X value is 10 because I want to find the speed when this ball is passing above. When it's passing the wall. Okay, are you with me? So let's find x is 10. So my x value is 10. This is tan 40 minus 9.8 into x square is 10 square over 2 times u square is 20 square, right? 1 plus tan square 40. Type the thing in the calendar and get me the answer. Type this whole thing in the calendar and get me the answer. So I type the whole thing in the cal. 10 into tan 40 minus 9.8 into 10 square, 2 into 20 square times 1 plus tan 40, and you can see around the tan 40 I have put an extra bracket around the tan 40 to give the power 2. Okay, whole thing square. So that you can see the y value. So clearly it's going well above the AB wall or the AB whatever the pole you have there. It's going well above because the AB is 2 meters while this is 6.3. So more than 4 meters above the ball will pass, isn't it? So y is 6.3034. Okay, so 6.303488. Okay, so this is not what I want, however. What do we need to do here? We need to find the speed at this point B. How do we find the speed at the point B? What is the easiest way to find the speed when you reach point B? So there are two ways to find the speed when you reach point B. Okay, so one way is where you actually find the vertical component and the horizontal component of velocity, and then you find the resultant. That's how you find the speed. So horizontal component doesn't change, while vertical component you can use v equal u plus 80, or we can use v square equal u square plus 2as. That's also correct. You could use v square equal u square plus 2as. We know everything, right? Yeah, so we can do like that. Or else we can even use conservation of energy. That's also correct. Conservation of energy, I think you are, because this is moving in this projectile path, energy is conserved. At this point, you have kinetic energy. Energy is scalar, right? Directions are not considered. And at this point, you have, at this point, you have, you need to find the speed, right?
Yeah.
Yeah, you have to find the speed. That's what you need to do. We need to find the speed. So basically, you have GPE and kinetic energy, which is like, which gives you the speed immediately. So it's up to you. If you want, you could find this is 20 cos theta is the horizontal component, 20 cos theta, and the vertical component Vy you can find by using v square equal u square plus 2as. You get me? Both methods are easy. No, none of them. Both of them are not that demanding. Okay, so shall we try the conservation of energy method? You don't need to find the horizontal component of velocity. It's constant throughout the entire motion, right? So 20 cos theta and Vy you can find by using v square equal u square plus 2as. Okay. So any method is fine. I will go ahead with the conservation of energy method because that directly gives me the speed. Otherwise, if I do this, I have to find the Vx, Vy and square root it to find the speed. They're asking us to find the speed. So basically, when I use conservation of energy, I immediately get the speed. So I immediately get the speed. Let's say the speed is x. So let's use conservation of energy at C. Conservation of energy. So I'll continue C over here because I want to have a look at my diagram. So let's use conservation of energy. So energy at O, what is the energy we have at O? Let's consider this as our GP 0 level. So at O, what do we have? We have kinetic energy, right? Half M20 square. Energy is scalar. That's not GPE. At the end, what do we have? At that point, we have half mv square, half mx square, plus we have GPE. What's the GPE? mgh. What is the h value? What is the h value here from A to B? The value we found for y, right? Because this is the vertical distance from the point A to the place where the ball is 6.303488. Do you get what's going on here? Okay, so now let's cut off the m value. M will cancel out, making what? X the subject. Multiply the whole equation with 2. I get here 2 cancels. 20 square is 400. The 2 cancels, I get x square. This one I get 2g into 6.303488. So make x square. Make x a subject. 400 minus 2g into 6.303488. So this is x square. When I find x, it will be the square root of this whole thing. X is the speed. Actually, I should have used half and v square, right? Maybe x is confusing. Is x confusing? You could use some other, because x might look like a vertical or horizontal distance. How much is v? Type the whole thing in the class. How much is v? Square root 400 minus 2 into 9.8 into 6.303488. And I end up getting 16.6. 16.6 to 3 SS. This one we don't, this is not work energy principle. Energy is conserved. Conservation of energy. Okay, so the energy you have at the beginning is exactly equal to the energy you have at the end. Okay, then the last part, find the distance OC. Who is C? C is the place where the ball hits the ground. C is the place where the ball hits the ground. Let's finish it off. It's just 2 marks. So you project the particle, it passes over the wall. This is point O. C is the place where you hit the ground. So starting speed 20, the theta. Okay, so what happens when you hit the ground? I think we can still use the equation. We can still use the equation, right? So when you hit the ground, what happens in the y equation? Y equal x tan alpha minus gx square over 2u square times 1 plus tan square alpha. I think the theta value was given to you as 40. This theta is 40. Okay, so what happens when you hit the ground? Your y becomes 0. Now, can we use x as 10? Can we use x as 10? No, you pass this point and you're going. Your point A was somewhere over here. The AB point was somewhere over here. Okay. The AB point was, so it has passed the wall and it's gone over here. Okay, so they are asking you to find the distance OC. Basically, OC distance is now what? The x distance. So what do you do again? When you hit the ground, y displacement is 0. X times tan 40 minus gx square over 2 times u square is 20 square. 1 plus tan square 40. Please type this equation. You will get again a what equation? It's quadratic. I think in this equation, there are only two parts. So we could actually take x out, right? X tan 40 minus type this part. 2 into 20 square gives me 800. So I get g over 800 times 1 plus tan square 40 into x square. So then when you take x out, we can factorize this because there are only two parts. When you take x out, I get tan 40 as 1 here minus g over 800 into 1 plus tan square 40. And there is one more x remaining here because I take one x out. So you can now factorize and say x is 0 or the tan 40 minus g over 800 times 1 plus tan square 40 into x is 0. Either this factor is 0 or this factor. Anyway, you understand when x is 0, y0 is the beginning. So the value you want should be definitely at this point. So tan 40 equals minus becomes plus, right?
Yes.
So I get g over 800 into 1 plus tan square 40. So when I make into x, so when I make x a subject, I get 800 times tan 40 over g times 1 plus tan square 40 equals x. Do you agree with me? So I get the answer for this 40.196. Which in the 3SF is 40.2 meters. 40.2 meters. Yes, and we have, this is the end of the discussion of this paper. I hope all of you understood this.